Hello, we are here for one more lesson of this T-FLEX analysis training course, and the topic for today inside the feature dynamic analysis, we have something called dynamic analysis features. So as all the other types of studies that we've seen previously, also inside dynamic analysis, this is performed in several stages. So we will describe the main steps to create this specific type of study. So first and primary point to work with this is the creation of the study. So as you know already, analysis, create a new study, and then we have the two possibilities we mentioned in the previous video, the mode superposition and the transitional process. Let us choose the second one. We then need to create what you know already, the mesh. I will create this relative mesh, and that's it. Then after this solved, we need to apply boundary conditions. And in dynamic analysis, as also in static analysis, the boundary conditions, what we call boundary conditions, are in fact loads and restraints. We can use all types of restraints and all types of force loads, the same that we can use in static strength analysis. We have other things that we can apply to this type of study, like the thermal effects and also some particularities inside restraints and forced loads, whatever. After this solved also, and I'm assuming that the material, it is, we can define it, but in this particular example, I'm using the material defined in the modeling of my solid in this particular case. So after everything applied, we will say solve the study. And as you know already, we can specify time for integration, and we can define a couple more things like the damping, the apply displacements, we can apply thermal effects. We've spoken already about this, and all or everything we defined in this dialog box will apply conditions, will influence the results we will get in the end. Then with the results, we need to analyze them. We can get several types of analysis, but it is important that in these dynamic studies, everything we obtain in the results, it will be influenced by time, and it can be studied in one specific moment of the study of time, or in one interval. Okay, so these are basically the major points to highlight for this type of studies. It is important also to notice that we can use graphics to check the result analysis, and it is something that we are going to see also. Better than explain all of these things, it is to create one very simple example using this model here. So I will simply delete this study now, and we will start from scratch. So I've created this simple bar. It is a rectangular bar with 1 meter in dimension and 100 millimeters wide, 20 millimeters thickness. So I will create a study, in this particular case a transitional process. I will create the mesh. We've spoken also about it. we can do it a little smaller. Instead of this, let us say 0.2, a little smaller, okay, better looking. So creation of the study, creation of the mesh, applying the material, you know, all of these concepts. The material I'm using, the one that was defined on the modeling. I can change it if I want, or change the characteristics of the material. For the moment I will leave it. Step 2, now we need to apply initial and boundary conditions. What we will do, it is to first apply a restraint, and I will apply a full restraint on the back face, this one. And now I will apply also a force applied on the edge. I will define the direction, reverse it, and besides this I will apply this according to a graphic which I will define now. So graphic, I can give it a name, graph2, it's okay, but I will choose polyline. So let's create a couple of arguments here with some data. So simply 3 points to create a graphic. And so I will say in terms of seconds, now here is 0, another one at 2 seconds, and another one at 2.5, 0 newtons, 500, and 500. And if all is okay, I have a graphic with, oops, let us zoom out, with this appearance, okay? Let us save it, it is done, and apply it. Now I'll create a sensor and a graphic template. So a sensor, I will create it in this point here. And I will create also a graphic template so that we can check after the result, applying this to the sensor. And sensor, I will measure, still not defined. So let us, for now, solve it first. And I would say I will study 2.5 seconds and increment, I can do it 0.05. Solve, I will leave all of this, nothing to worry about. And let us wait a little to have the result from the study. So it will grow until 2.5 seconds. So now I will check my my result for displacement magnitude, as you can see. And I can go to the displacement magnitude and create a graphic using the sensor 1, that, as you can see, this is the result of the sensor 1. It has a displacement, and on the top we have some oscillation with very small amplitude when we apply this 500 newtons force. So it is something that we can check with this graphic. It is interesting. So, and it could be better defined if we lower the step that we apply to the time of the interval of time that we've applied. So we do this, we could do the same comparison creating a mode superposition, but basically we would obtain something very similar to this result. But this is to show you what kind of procedure we can create to have this dynamic study done. We have also analysis for equivalent stress, which we can check also with this kind of look. And in this particular one, we have also the factor of safety, okay, which we can check also with the limits and with the parameters that were defined that I did not check, but it will give you an example. But with this, I think it is clear that it's not very hard to create the study, and we can very easily create some graphics to define and to create a better analysis of what we are studying. In this particular case, only to this bar, but if we have more complex systems, we could do the same. So I hope it is clear, and if you need any additional help for this type of studies and for the topic that we presented in this lesson, so send us a contact and we will give you all the support.